Hello, this is Mrs. Sargent, and this is lesson 4.4, Naming and Writing Formulas for Covalent Compounds. First, let's talk about the difference between an ionic versus a covalent compound and why they have different bonds. We wrote this in on the bottom of page 9 in that extra margin space that you have. In ionic bonding, the valence electrons are transferred. Shown on the diagram on the right, lithium is going to lose its one valence electron, and fluorine is going to gain it. That makes lithium a positive or a cation, and fluorine a negative or an anion. Because of the high electronegativity difference, the elements involved in ionic bonding form these ions. And these can either be a positive cation or a negative anion. In covalent bonding, the valence electrons are shared. The prefix co means to share. If you've been a co-captain of a team, you share that position with someone else. My 8th grade basketball team was co-city champs. We shared that title with another school in town. The electronegativity difference between nonmetals is low, and therefore in covalent bonding, valence electrons are neither gained nor lost. So covalent or molecular compounds, they contain a nonmetal and another nonmetal, or a nonmetal and a metalloid. So we have prefixes that are going to designate how many atoms of each element are in the compound. These prefixes, the prefix for 1 is mono, the prefix for 2 is di, the prefix for 3 is tri, like a tricycle, 4 is tetra, 5 is penta, like the pentagon, 6 is hexa, like a hexagon, 7 is hepta, 8 is octa, like a octagon or an octopus, 9 is nana, N-O-N-A, and 10 is deca, like a decade. These prefixes are located on the backside of your periodic table in the right-hand corner. So rules for naming covalent compounds. The first thing that you're going to do is you're going to name the first non-metal compound, so the first element in your compound, and then you're going to add a prefix. But we never use the prefix mono on the first element. The second thing that you have to do is name the second nonmetal and drop the ending, add "-ide", and you also have to add the prefix. So we have a couple examples here. CO2, my first nonmetal, C, is carbon. I only have one, but I'm not going to use the prefix mono because it's the first element. And then O2, so my prefix for 2 is di, and it's oxygen. Change the ending to "-ide, so dioxide. And then we have P2O5. The prefix for 2, again, is di. P is phosphorus, so diphosphorus. O5, the prefix for 5 is penta, so it's pentoxide. We dropped the A off of penta, so you don't have a double vowel there. All right, here are 4 more examples. Go ahead and pause the video and try these on your own. Welcome back. So we have SO2. This is going to be sulfur dioxide. CCl4, this is carbon tetrachloride. SF6, this is sulfur hexafluoride. And then AS2O3, this is diarsenic. Trioxide. There are a few examples that are going to go by the common name versus the scientific name. One example of that is dihydrogen monoxide. This is also commonly known as water. Ask your parents tonight if you can have some dihydrogen monoxide to drink with dinner. Then you can explain to them the chemistry behind that. Nitrogen trihydride is ammonia. Not to be confused with ammonium. This is not ammonium, which is our polyatomic, our only positive polyatomic. So ammonium is NH4 plus, ammonia is NH3. And then carbon tetrahydride, this is methane. This is the gas that fuels our Bunsen burners. It is also found in cow farts. And then the rules for writing formulas of covalent compounds. The first thing that you're going to do is write each element symbol, and then turn the prefix for each element into the number and write it as a subscript. So disulfur trioxide, S for sulfur, 2 for my prefix di, trioxide, so we have oxygen, and we have 3 of them for the prefix tri. Then we have phosphorus pentachloride. So phosphorus is a P, chloride is Cl, penta is 5. You have 2 more examples. Go ahead and pause the video and try those on your own. Welcome back. Dinitrogen monoxide, N2 for di, O. And then heptadiphosphide, or heptacarbon diphosphide. So carbon, hepta is 7, phosphide, phosphorus, and we have 2 of those for di. So C7P2. Now, there's some covalent compounds that don't follow the naming or rules, and those are diatomic molecules. This is when you have 2 atoms of the same element that are naturally found bonded together in order to achieve stability. I call these the Brinkelhoff twins. Br is for bromine, I is for iodine, N is for nitrogen, Cl is for chlorine, H is for hydrogen, O is for oxygen, F is for fluorine. So each of these are always going to be found in a twin, or they're going to be found bonded to something else. You're never going to just have a single bromine atom. And I told you that these don't follow the prefixes for naming. The name of these is just the name of the element. So if you're given this name bromine, the formula for it is Br2. So I2 is iodine into nitrogen. Cl2 is chlorine. H2 is hydrogen. O2, oxygen. F2 is fluorine. You need to work on practice J that deals with covalent naming. I also want you to take a look at practice K, which is previewing the difference in properties between ionic and covalent compounds. We'll talk more detail in that in class. I just want you to go ahead and take a look at it. Thanks for stopping by. Have a great day.